right, so 8.3. So we want to change this to polar. So this is a X and Y coordinate. Also called rectangular. So rectangular point. It's on the XY grid. So change it to polar. So we should know that we need to change X, Y to some R and theta. So we know that R is equal to plus or minus the square root of X squared plus Y squared. So just choose the positive because they told you R is greater than 0. So plug in the X, plug in the Y, and we'll get what, 9 plus 25? $34? Yeah. And that doesn't reduce. Well, I'll just leave it that way. So we have the R part. So square root 34, right? That's all you have to do. I get theta. Use the tangent formula. I told you that theta is equal to tan inverse of y over x. So that would mean that this is equal to tan inverse of negative 5/3. So calculator in degrees. So this is approximately negative 59 degrees. We'll say point, I don't know, 0.04. So add 360, get the co-terminal angle, so we don't use a negative. As I told you right here, theta needs to be between 0 and 2 pi. This is negative. It can't be negative. So just add 360. So this would imply that we have to add the 360, which gives us 300.96 degrees. And that's it. So we have R and theta. I'll just write it down here, a little prettier. So 3 negative 5 will become square root 34, comma 396. Step 1, find R. Step 2, find theta. Okay. Any questions on the work? Is it okay? Did you use the formulas I gave you for converting? That's cool on example 8. Oh, wait a second. Right. Example 9. We'll do that other direction. Change the following to rectangular. It's the same as Cartesian. Okay. So the goal is to change 5 pi r theta into some x y. Oops. So we're going to need the formulas that x is equal to r cosine, y is equal to r sine, so just plug in the r and theta, and that's it. Nothing crazy. So this will become 5 cosine pi. This will become 5 sine pi. What is cosine of pi? You remember? The unit circle is going to be -1, right? So just plug in -1 and you're done. You have the x value. Sine of pi is 0, correct? So at that point, you get 0. So your answer will be -5, 0. Any questions on number 9? Is that okay? Yeah, it's just an angle. Just plug it in. If it's a weird angle, use your calculator. You'll just have you end up with you'll find it with decimals or something. But if it's an easy angle like pi or a known angle, use a circle. We can see though, right, that this is the same location if you graph it. 5 pi is up here. Over here. And -5, 0 is the same. See what I mean? Like if you use the angle, maybe said go all the way to pi, go out, whatever it is. You go on the side. 1.5. And -5, 0 is 5, and then you have 1. You end up in the same thing. They should be the same location. I didn't ask us to graph it. I just wanted to show you that these are the same. Okay. All right, you guys cool on 9? All right, let's convert equations instead. So it probably has some questions about point conversion, and then we'll have actual equations. No, oh, wait a second. Right. Example 10, right? Yep. So convert the following rectangular equation to polar. So you want everything in terms of r and theta. Okay, so no x's and y's. Remember, the x's are cosine, y is r sine. So you got to do the substitution and maybe use identities to change it. Also, we should know that r is equal to square root. I don't know if we'll need this, but I'm just going to give them to you. R is square root of that, and then r squared is equal to the sum of squares. Okay. So take this equation and substitute. You'll plug in your cosine, plug in your sine, plug in that other cosine. Okay. Yeah. How we should. Thanks. Almost forgot. Yeah, it's gonna be. So we have to square both parts. So this will become, when you square a product, right, and we square each factor. So r squared cosine squared plus r squared sine squared equal to 3r cosine. Right away, you should see that this is a Pythagorean identity, right? If I factor the r squared, you see that this is 1. So this will just become r squared times 1 equal to 3r cosine. This is because we know, my pen's running out. We know this is true. So at this point, it's pretty much done. And I'll give you majority points if you get to here, right? But usually you want to solve for R. We could divide an R out. We could take this guy divide by R, this divide by R. Let's put a square back. So that'll cancel this one. Cancel one of them. Our final answer will be this. So the goal is to have it solved for R if it's possible. So at the very end, just give me R equals something. Okay. If you can't get there, but you do replace all the X's and Y's, then you got a majority of the points because it is converted. It's just not simplified. Okay, like technically, right here, I have already gotten to polar. Right. It's just this is much prettier. Any questions on 10? Do you see the algebra okay or substitutions? Okay. Do another one, a harder one. So we'll be going from polar to rectangular, other direction. Example 11. Write the following polar equation to rectangular. Okay, so I need to change the X's and Y's, so we need to know or remember the Y and X is equal to this. I don't think I'll need this. But I'm gonna write it anyway. What I want you to do, basically we'll have to multiply both sides by the, let's just start it right here. By the denominator. So multiply this side by sine theta plus 7 cosine theta. Multiply this side times that same thing in order to cancel that denominator. Since I'm doing it to both sides, it's fine. So you see how it's going to cancel this on the bottom, right? This is gone. So the first step is cancel the fraction by multiplying both sides by your denominator. So now I have r times sine theta plus 7 cosine theta equal to 4. That's a lot prettier. with all this canceled out.
How do you get the R on this side?
Oh, this.
Oh,
So I just multiply this.
oh, and then you just move the 4. And then you move the denominator of the 4. Like on the other side.
Yeah, so put the denominator, the multiply here, right? And here. So this is what I introduced. The original didn't have one. So I put that here and there to cancel this. Now I just that's the goal. You can always cancel fractions if you have an equation. Just multiply by LCD, but since you only have one denominator, that is the LCD. You don't have to worry about it.
Yeah, I was just a little bit confused. I was worried about the R on this side. But
Oh, you see it's for the original R. I got you now. So at this point, just distribute. Do you see now that we can now convert, right? What is R sine? Yeah, we're pretty much good. R cosine is right there. So do you agree that this is 7x? We no longer have any R's and thetas or sines or whatever. We are now in rectangle. So that's the goal. On the homework, I don't know if you remember, sometimes you have to get creative to try to set it up, make it turn out like this. Sometimes it's pretty obvious once you do a couple of steps. It depends. Just remember your goal is you want an R and a sine, R cosine, or something like that. Okay. Any questions on 11? Well, I guess we should solve for y, technically. That's a good point. We could subtract the 7x. I think that this is a little better. If you can solve for y, go for it. But if not, if it's like all complex, just leave it alone. Anyway, that's pretty much it for 8.3. Let's move to 8.8. I think that'll be the, well, maybe not. No, 8.8 is kind of long. Yeah, the last section for the homework or the review will be 8.8.
so we're not just want to include that.
No. Let's focus on the stuff we've talked about. Yeah. If it wasn't on the review, I wouldn't worry about it. All right, find the position vector V, then find its magnitude. And direction given that P is -1, -1, and Q is -4, 5. These are 2 points. Find the vector that goes through them, and then find the magnitude and direction. Okay. So vector V, we said is going to be, if you use the IJ component of notation, you subtract the second point minus first point. And then you subtract, this is the X values, right? Or the I's, -4 minus this one. And then for the J's, you take the second one minus the first one. If you prefer the other notation, it would be like this. -4 minus a -1, comma, 5 minus a -1. Right? So this top one will become -4 plus 1. This will become 6. J. So use whatever you like. I don't care what format you use. Just make sure you know both of them. We use both interchangeably in the notes, and the book does the same. So I want to make sure you know that it's the same thing. Okay. The I's would be A. J, the X. First, the final X minus initial X. Final Y minus initial Y. It'll always be that way. So once you have your vector, find the magnitude. So the magnitude of V, we said is equal to the square root of each component squared. So that will be what? 9 plus 36. Now we know that 45 contains 9 times 5. Right? This would be the reduced form for the square root. That's the length of your vector. Okay. Now the direction, they mean find theta using your tan inverse. So that means that theta is equal to tangent inverse of this component over this guy. So calculator time. What is that? -2, right? So -63.4 degrees. Since it is in quadrant 2, you would add 180 to get the coterminal. So this will be our answer. Of course, you can choose either one. Okay, so yeah. I give you a list, you remember? Depending what port or what quadrant you're in, you do something different. So some we're doing what was it called? Co-terminal and reference angles. The very beginning, when we first started talking about the unit circle.
But in a way, like if it's negative, then you would know, like if it's in quadrant 3, then it would be, would you add 1 digits to it, or would it be 2?
This quadrant 1, you just leave it alone.
Yeah.
This quadrant 2, you add 180. This quadrant 4, you add 360.
So 3 would it be 2?
3, I forgot. Let's look it up. Have to check. Yeah, there's a rule for each one, each quadrant. What was 3? Anyway, you can look it up later. Okay. Any other questions on this example here? Given two vectors, u equal to I plus 5j and v equal to negative 2i minus 3j and w equal to 4i minus j. Given these three, for part A, find that u plus v minus w. Find that new vector. So just add and subtract all the components and the corresponding components. You should be good. So this will become I plus 5j plus whatever this is. And put a bracket since it's two vectors going on in there. Make it a little neater. So this will be vector v negative 2i minus 3j minus 4i minus j. So at this point, what I would recommend is distribute that negative and then group all the i's and all the j's together. That way you don't mess it up. These first set of parentheses are doing nothing. I just put them there so you can see that that is U, vector U. Same here, this is doing nothing for vector V. But this will distribute, so you get a minus 4i plus j. So you swap your signs with that negative. So now remove all the parentheses and group everything together. So minus 2i minus 3j minus 4i plus j. So this will be I minus 2i minus 4i plus 5j minus 3j plus j. Okay. A lot of i's and j's. Okay, so I'm just putting them together. That's all I'm doing. Okay, so 1 minus 2 minus 4. I think let's go ahead and put it. Negative 6, 1 minus 6. Right. 5 minus 3 plus 1. I believe that's 3j. If you wanted to combine in here first, you can, it doesn't matter. You're just, all you're doing is combining like terms. You have combined like terms many times in the past, right? Right, it's about 3 it's the same thing. The only thing that's new is that they represent vectors, right? Same deal. I don't have room for part B, so I'm gonna turn the page in a moment. All right. You guys cool on part A? Part B, using the same vectors, can you find 4v minus 2u? So we're using a scalar and then we're going to subtract them. So scale v by 4. So in other words, multiply it by 4. And then scale this guy by -2. And we'll get -8i minus 12j minus 2i minus 10j. You want to group the i's together, go for it. And the j's. Just combine your like terms. So the new vector is this guy. You could also use the other notation if you want to. All right. Move on to a different question. You guys cool on part B? You see, we're just multiplying these two numbers and then combining like terms. Is that all right? All right, so we'll move on to something else. Find the unit vector of u. In the direction of v. So let me give you the formulas. Remember that these formulas mention a comma b as your I and j parts. X and y, I guess. Or you can write it as ai plus bj. It depends. We also said that the formula for magnitude is a squared plus b squared. So I'm gonna go ahead and give you all the formulas here. And unit vector u is equal to v divided by its magnitude. That's all they mean by unit vector. Find the magnitude of the v they're talking about and divide it by this. Okay, or divide it into it with that same magnitude. Okay. So we got v, magnitude of v.
The denominator is the magnitude of v.
Yeah.
Oh.
V. Yeah, they both look like v's, huh? Sorry. So 3 and 4 are the A's and B's. Square them, add them up. That will be 5, right? So now take your B, divided by 5. So unit vector u is equal to V divided by its magnitude, which will be 3i plus 4j divided by 5, which gives us 3/5 I plus 4/5 j. That's all you gotta do. Okay, let's do 2 more examples, and I think that'll be it. Okay. You guys cool on example 14? All right. I know it's a lot, but make sure we cover every type. So for 15, just do the dot product. I give you 2 vectors, u and v, just multiply them. But it's a vector multiplication, it's not a true product. It's called a dot product. So you will get a number back. You will not get a vector. Okay. So u dot v, you just multiply the I components plus the j, and then multiply the j components. And that's it. It'll be -6 minus 6. Just so happens they're the same. We get a number -12. That is it. Last example. You guys cool on 15? You remember dot product. The last one will be finding an angle between 2 vectors. So find an angle between u and v, given that u is -3i plus 4j, and v is 5i plus 12j. So the formula for angles between vectors is this: cosine inverse of u dot v over the magnitude of u times the magnitude of v. So first find the dot product. Those are a dot product. We will get negative 15 plus, is that 48? So there it is. 33 will be at the top. All right. Now we need each of the magnitudes for u and v. The magnitude of u is equal to square root of 3 squared plus 4 squared and u will be 5 squared plus 12 squared. Then these both happen to be magical triangle types. So on the bottom, you'll have 5 times 13 inside the formula. Okay, so now we can use the formula. We got every single piece. Just plug it in. Yes. Like what order? Or what do you mean? What's bothering you? Okay. It should have been V 3 and 4, right? U. Oh, I see. Yeah, I think I mislabeled them. This should be U. This is U, and this is B. I don't know why I call this B. Is that what you're talking about? Yeah, there we go. The magnitude of V is 13. The magnitude of U is 5. So the formula, just plug in 33 from the dot product divided by 5 and 13 and plug it into your machine. And that's it. You'll have an angle between both vectors. It'd be about 59 degrees. So the angle between both vectors is this.
Yeah, it's just.
Yeah, that's the angle between two vectors. So all you have to do is use this formula. It's just that formula requires you to do some work. Okay. So once you get all that stuff, just plug it in. So exam 3, I'm not gonna put any 8.5 questions. Questions should be similar to what we talked about on the review. Okay. Do you have any concerns or questions about anything? Yes.
Will you be planning on the sheet?
No, just put whatever any formula you want, just no examples. If you need advice, let me know, but. All the formulas I've given you on each section, I'll put those in chapter 8. Vectors, all the vector formulas for sure, the conversions from polar to rectangular, all those. But yeah. Usually I write the formulas at the beginning of every lecture, just copy those. If you need more, then I'll leave that up to you. But let me know. Guys have any other questions? All right, guys. Well, we'll stop here then. If you want to talk to me after for free, I'll be here for a while. I have another class in like 20 minutes.